In our previous video, we saw that an object which is not interacting with other objects can do one of two things. It can either sit still, that is, not move at all, or it can move in a straight line at constant speed. Now, if an object is doing one of these two things, is it getting faster or slower? Right? An object sitting still is not getting faster or slower. An object moving in a straight line at constant speed is not getting slower. Okay? If an object is doing one of these two things, is it changing its direction of motion, like turning left or right? Well, an object sitting still is not changing its direction of motion. An object moving in a straight line at constant speed is not changing its direction of motion. Okay? So an object not interacting with other objects cannot change its speed, and it cannot change its direction of motion. So what must need to happen in order for an object to change its speed or direction of motion? In order for an object to change its speed or direction of motion, it must interact with other objects. These interactions between objects that allow the objects to change their speed or direction of motion are called forces. So in the rest of this video, I'm going to go over some basic ideas which apply to all forces. And then in the following videos, we're going to start going one by one through the four forces which come up over and over in this course. Okay. So first thing, does a force have a direction associated with it? Well, here's what we can do. I'm going to take this air puck from last time, and I'm going to push the air puck in different directions. I'm going to push it right, then left, then forward, then backward. And we're going to see if those pushes in different directions yield different results. Okay, so I'll turn on the air like last time so that I have frictionless motion. All right, so now I push to the right. It starts moving to the right. Now push to the left, starts moving to the left. Push forward, it starts to move forward. Push backward, starts to move backward. So it looks like when I apply forces in different directions, the resulting motion of the object is different. So it seems that forces do, in fact, have a direction associated with them. Do forces have some other numerical value associated with them that isn't quite the same thing as the direction? Well, this is an experiment you can do from wherever you are along with me. So I have this set of weights here that I'm going to start stacking onto my hands. So you can do this along with me with whatever objects you have in vicinity, preferably maybe the heavier objects in your vicinity, maybe books. But let's say I just put my hand out. I'm going to put that mass on top of my hand. This weighs about 2 pounds. So right now, gravity is pulling down on this thing with about a 2-pound force, and my hand is pushing back up with a 2-pound force. So 2 pounds in either direction, and I can feel that interaction, right? I can feel that interaction between the object and my hand. Okay, take another object. Now we have a force of about 4 pounds. Gravity is pulling down with about a 4-pound force, and my hand is pushing back up with a 4-pound force. I can feel that 4-pound interaction between the object and my hands, right? Now I can feel an interaction of about 6 pounds between the object and my hand, right? Now I can feel an interaction of about 8 pounds between the objects in my hand, right? So as I stack up more stuff on top of my hand, I can feel the strength of the forces exerted between my hands and the object increase, right? So we can see that force has a numerical value associated with it, which is separate than the direction of the force, right? That numerical value associated with the force that's separate from the direction of the force is the strength of the force. Okay, so a force has a direction. A force has a numerical value associated with it separate from the direction of the force, that numerical value being the strength. Okay, so what has a direction associated with it and also a numerical value associated with it? That's something we studied in class recently. That would be a vector quantity. So a force is a vector quantity. Okay. Next thing we're going to cover here is the unit of force. And we studied units already in this class. The unit of length we tend to use in this class is meter, although there are other units of length. The unit of time we tend to use in this class is the second, although there are other units of time. So what is the unit of force, or at least what units of force are we going to use here? Well, the unit of force, which likely you are most familiar with, is the pound. Now, what does it mean to say that an object weighs a pound? Well, imagine I have a pound of bananas sitting in my hand here. What does that mean? It means that gravity is pulling down on those bananas with a 1 pound force. And if I'm holding the bananas steady, then I would be pushing up on the bananas with a 1 pound force to balance the pull of gravity. So pound, which you're already familiar with, is a unit of force. However, there's another unit of force which we're going to be using much more often in this course, which is the Newton. Okay. All right, so the unit of force used in this class is the Newton. Okay, symbol for that, N. Okay. And we can relate the Newton to the pound, right? We have a conversion factor. So it turns out 4.45 newtons equals 1 pound, or say a Newton is equal to a pound divided by 4.45. Notice that a Newton is about 1/4 of a pound, right? What weighs 1/4 of a pound? A 1/4 pounder, right? So a Newton is equal to about the weight of a 1/4 pounder, or a Newton is about the weight of a hamburger patty, right? They could have called it a Newton burger instead of a 1/4 pounder. Okay, so to summarize this video, we've learned that in order for an object to change its speed or direction of motion, it must interact with other objects. Interactions between objects that allow the objects to change their speed or direction of motion are called forces. We've learned that force is a vector quantity. It has associated with it a numerical value and a direction. And we've also learned the unit of force that we use most often in this class. It is the Newton. A Newton is about 1/4 of a pound, or about the weight of a hamburger patty or 1/4 pounder. Okay, so after this video, there's one more video where we're going to go over some basic information related to how we understand forces. And then after that, I'm going to start introducing you to the 4 forces that we use most often in this class.